Welcome to another video in my Modern Architecture series. My name is Jesper Scherpenhausen, and in this video we're going to be talking about 7 of 9, Star Trek, the Borg, but most of all Kubernetes. But before we dive into that, it's always good to take a step back, have that 10,000 feet overview, and look at the history. Where did we come from? So if you look back something like 20 years ago, everything had to be deployed on bare metal, so on dedicated hardware, running an operating system, which would then in turn be hosting your applications and your services, which is of course, well, by definition, not scalable. Well, maybe vertically if you have that option, but absolutely not portable from one system to the other. And then, of course, maybe 15 years ago, you saw the actual start of virtualization, where you saw dedicated hardware running operating systems, but then instead of actually hosting the applications, it was then used to run a hypervisor, which was then able to manage virtual machines. Well, the downside of those virtual machines, of course, was that each one of them had to have their own operating system, and then in turn have all of their applications running there. So this was a great step towards portability and scalability, but it wasn't the end yet. And then if we look back to 2013, so when actually the first version of Docker was released, we saw that whole concept of containerization really starting to get a foothold. And you start to see that you don't necessarily need to have containers with their own operating system. You might actually have a lot of shared components that can be shared by containers there as well. So the containers themselves become much smaller, but because of the core concept of those containers, just like physical containers, any container you get will always fit because of that standardized interfacing that you have, makes it that much easier to scale and to port from system to system. The container you developed on your laptop will run just as fine in production because of that same interfacing. So the question then becomes, how do we actually manage these containers? Because you have your hypervisor, of course, for virtual machines, and you've got your container runtime for Docker, for instance, but you want to have one layer on top of that where you can actually say, well, this is what I need to run, and I want the system to monitor and make sure that everything keeps running there as well. So one of the first organizations to realize that was Google. And Google then started to develop a system, or a platform, I should say, called Borg, named after the, probably best known enemies of Starfleet in, Star Trek. So the Borg were essentially a connective collective that had no free will, but just executed what the collective demanded of them. And this was then developed by Google engineers. And after a while, some of these engineers actually said, well, we're going to develop a more open approach, so it's no longer built in C++, but rather in Go. And they called that Project 7. And that was indeed in reference to 7 of 9, the Borg drone that was freed from the collective by the crew of the USS Voyager, and then joined the crew and fought the actual Borg. So this was the good guy, or in this case, good girl Borg that we all know and love. But then again, they renamed it Kubernetes, and as you see in the logo, you still have a wheel with 7 spokes in reference to Project 7 and in turn 7 of 9. So that all as an introduction to what we're going to be talking about. So what are we actually going to do in this video? I want to show you how you can use Kubernetes first to set up your Kofax RPA environment, how you can run that, how you can then use that to monitor that. I'm also going to show you how you can use a Kubernetes dashboard so you can actually visually confirm that everything is up and running. And then one of the key features that Kubernetes adds is auto scaling. So depending on the load of a container, or in Kubernetes terms, a pod, you can actually scale additional pods up and down within a single deployment. So I want to show you how to run RPA. I want to show you how you can then monitor RPA, and then I want to show you how you can do auto scaling. So to make it a bit more practical, I'm going to send a lot of robot requests to RPA, and we're then going to see Kubernetes actually adding additional roboservers to the cluster in order to handle all of that load. So if you want to follow along, what you'll need to have your running copy of the Docker desktop. You'll need to have a proper terminal client. I like to use the Windows terminal, and I also need everyone to have access to a proper text editor. I like to use Visual Studio Code because of the YAML highlighting and a lot of the other reasons why I love that. But if you want to use Notepad++ or Sublime, feel free to do that. And what you also need is you need to have access to the Kofax RPA images on a Docker repository from the previous video. So what you can do is you can either go back to that video and make sure that you have access to it, or you can use my repository. And as always, my repository is just my personal playground. No guarantees on that. It's not officially condoned by Kofax, but if you want to use that for this exercise, feel free to do that. So once we have that, the first thing we need to do is we need to make sure that we are running a Kubernetes cluster, and that's where Docker Desktop comes in. So open up your Docker Desktop, give it a second, and then go to Settings, Kubernetes, and Enable Kubernetes, and Apply and Restart. So what this does, it actually starts a local Kubernetes cluster. And what that actually means, I'm going to explain that in finer detail going forward. So this is what we are actually running. So this is your cluster that you're running on your local machine right now, where you have the actual control capabilities of Kubernetes running, and you have one single node, because that node is of course your machine. Within that node, you can then deploy pods. And how we do that, that's what we're going to dive in right now. So theoretically, you could actually drop to the command line and run all of those commands from there, where you say, I want to have this pod deployed that needs to be connected to this X, Y, and Z. But it's much easier to use what's called in Kubernetes terms a manifest. And if you have a look, you might actually start to see some overlap between a manifest and a compose file, in Docker terms, so to say. So what I have right here, this is a very rough first draft of a reusable, well, manifest. So I've got a lot of things commented out. So I've got some comments there. If you want to have a dedicated namespace, and which is probably not what you want for your very first one, but you have that there as well. I'll be uploading this to GitHub, by the way. So I'll put a link in the description below, and you can just grab this copy and use it for yourself. One thing you need to decide up front is where you want to have your database running. So you can, of course, deploy a database to your node and run it as a pod. But keep in mind that if you don't configure it further, that is just going to be, well, it's going to be volatile. So every time you restart that pod, you have to start from scratch. So in my scenario, I'm actually going to be using an Azure SQL server. So you see that going forward. But if you don't have access to Azure, or if you don't have access to a SQL server or a MySQL server, you name it, you can just run the volatile local one. So you can then just uncomment this and keep going forward. So what we're actually going to be doing in this manifest, we're going to be defining services and deployments. That's the first thing we're going to do. So the service is actually that which we want to expose. So the first service that we want to expose is indeed the management console, and we're going to expose that on port 8080. And what then actually is that management console? That is then defined in the deployment. So don't think that the deployment would then be the actual container. No. This is just the grouping of containers, because we want to be scaling across all of these deployments, where you have 1 to n possible copies of the management console, or in this example, we're going to be running multiple copies of the roboserver. So you do see references to Docker repositories. So here you have the reference to my personal one, and you can just grab that and reuse that. But if you've done this in the previous video and you followed along, you can use your own references there as well. Keep in mind that if you want to use Microsoft SQL Server, you need to have created your containers with the SQL driver included. If you've got any questions about that, feel free to reach out to me. The other thing that we need to do is we need to make sure that we define the actual resources that we want for that deployment. So if you then say, well, the limits are this and the request at start should be that. So this is then a quarter of the CPU, and this is of course the full CPU. And just like with the compose files, you also have to set the environment variables there. So as this is a clean one, this is of course not my actual credentials that I'm using for my Azure SQL environment, but you just have to have your SQL user, your very own safe password. And if you want to use a local one, you can just uncomment this and comment out the SQL Server on Azure. And also make sure that you have your production and non-production key there as well. Of course, if you want to do auto scaling and you really want to push the environment, you'll need to have more than one concurrent robot. So either get your own non-production license. So if you have a very recent copy of Kofax RPA, you would have unlimited non-production robots, and that's of course very usable for these kind of exercises. And if you don't have a license, I would recommend to reach out to your local Kofax representative, and they will probably be able to help you out with a test license. So that's what we're going to do for the management console. And then we also have the roboserver. That's the thing that we want to be auto scaling. So it's exactly the same. So we have a service that we're going to be exposing, and we then have the actual deployment. So you can see everything is set like this. And we then of course make sure that the roboserver will announce itself to the cluster with credentials, and it's going to do it like that. And then of course we also have the auto scaling thing. So what I'm going to be doing first is I'm going to be commenting this out. So I don't want to enable auto scaling from the start, and I just want to show you what this does. And then afterwards I'm going to activate auto scaling, and you can actually see what that causes on the machine. And then we're going to put a lot of load on the system, and we're just going to see additional robo servers popping up. And then of course after a while they'll be spun down as well and decommissioned. So before we actually get RPA up and running on Kubernetes, we also want to have the metrics server and the Kubernetes dashboard running there as well, so we can actually have a good grasp and see visually what's happening. So in order to do that, we need to run some commands, and all of these commands will start with kubectl, which is the Kubernetes execution command. And the first thing I'm going to be doing is indeed install the metrics server. So I've made some changes to the manifest, mainly so that it accepts self-signed certificates. I'll share my version with you guys as well. So we are actually applying that manifest to our Kubernetes cluster, which will then in turn make sure that we have the metrics server up and running. Then the next manifest we're going to be applying is the one for the dashboard itself. So this is actually quite interesting. So you can see I can actually just grab a manifest straight from GitHub without downloading it first and then applying it straight away. What we then need to do is we also need to create a user for the dashboard, and I just do that with create service account specifically for the dashboard. So that's done, and we then need to bind that to the right environment, of course. And once we've done that, we grab the actual secret that we're interested in. So this is the one we want, and we then just want to ask the system, well, please describe that for us, so we actually get the token in hand. Here we go. There we go. That's it. This is what we want. But before we do that, we need to start the actual proxy so we can actually get to the dashboard. There we go. And we grab the actual token itself. So open up, well, in this case, Firefox. Any browser will do, of course. And what we need to do is we need to open up this URL. And again, all of these commands, all of these URLs are going to be in the description below, so don't you worry about a thing. So grab the token again, copy that, remove this one, paste the new one, and save it for now. You never know when it comes in handy. And we now see that we have our services up and running. So this is where you can actually go and select your namespaces that we mentioned before. I'm just going to stay and keep it on default, but I do want to show you that if you select all namespaces, you'll already start to see all of the internals of Kubernetes running there as well. So once we have this up and running, you can go through all of these, and it goes beyond the scope of this video to explain all of the capabilities within this dashboard, but please have a look around. It's pretty self-explanatory if you ask me. And the next thing we need to do is we need to actually, well, apply the RPA manifests too. So I'm just going to grab another tab there and just paste kubectl apply-f RPA.yaml, and of course change that to your own manifest that you have. What you'll then see is that it indeed creates the service for the management console, the deployment for the management console, and the same for roboserver. And you already start to see some changes being applied here to the dashboard. So if we then go to deployments, you'll see that we have a deployment for the management console and we have a deployment for the roboserver. Each one will be deployed to one pod. So we will have one copy of essentially the Docker container running. And what we can then do is we need to, of course, open up the management console so that we can actually confirm that it's working. Localhost 8080, of course. And we're going to wait until the management console is up and running. And there you have it. So let's log in with admin. Don't save that for now. So, and the first thing we want to confirm is that we have indeed one roboserver up and running. There you go. That's one roboserver ready to accept new robot runs. What we can then do is we can indeed apply the autoscaler rule, which says that we want to have at least 2, but maximum of 10. We can do that by uncommenting this and reapplying the manifest. But everything that you can do in the manifest can also be done from the command line. So I do want to show you that real quickly as well. So we're going to grab this command, go back to the command line. And of course it starts with kubectl because it's a Kubernetes exercise. Autoscale deployment roboserver, aim for CPU percentage 75%, minimum of 2 and a maximum of 10. So if we then run this, we can actually go to the environment here and you'll actually start to see pods being ramped up. So we go to the deployments, roboserver, and you'll immediately see that the autoscaler is already there. So this is the new rule that we've applied. And what we can then do is we can just wait for a new event to appear that's going to tell us, okay, well, we are actually ramping it up to 2 roboservers. And what we can do after that is we're just going to put the system under load and we're going to see how quickly the system responds by actually ramping up additional roboservers. So just wait for a couple of seconds. I expect this to take, well, maybe 10 seconds until we see the new event popping up. It's typically done after a minute or so. So it's going to be a couple of more seconds. There we go. And we now see that a new event was raised. Current number of replicas below spec minimum replicas. So it's now scaling up the replica set for roboserver to 2. This is of course exactly what we wanted to see. So if we then go to pods, you'll see that we have indeed 1 management console and 2 roboservers. So this one was the original one and this is the one that we now have added. And if we then go to the management console and see, and we can wait until the second one actually appears, but it's already there. So we now have 2 roboservers. What we can now do is indeed put this system under load. So what I've done, just like in cooking shows, I have a number of robots here that will help me to actually stress test this machine. So I can just run a couple of these robots as much as I can, and you can actually start to see what's going to happen. This is a combination of desktop automation and just regular web automation robots, and we can immediately see that if we then have a look here, that these roboservers are immediately executing all of these there as well. So we have a nice queue of robots that they need to work through, and what we can then wait for is to see how quickly the system responds by adding additional roboservers. So we're going to go back to the deployments to roboserver, and we can actually see that it's not recognizing it yet, but if we then have a look at the pods, you'll start to see that these are now ramping up the CPU usage and also the memory usage. So just give it a couple of seconds and you'll start to see beautiful things happen. There we go. So you already start to see some changes there. So what we can then do is go back to the deployments and have a look at the roboserver there, and it's still at 2. So we might need to run some additional robots. So go back to the repository and fire off some additional robots, and let's see how quickly we can get this system to have at least, well, maybe 8, 9 or 10 roboservers. So just run this, add this to it. There we go. And we can then wait for the actual system to say, well, now it's been too heavy for me, so how can we actually handle that? That's of course by adding additional roboservers. So we can now finally see what's happening to these roboservers, and if we then go back to the deployment, I actually expect something to happen there as well. So give this maybe another minute or so and we'll start to see this ramping up. So another thing happened right here. So it's now saying, well, we want to have 4 roboservers running, so we can see that those will now be spun up. So if we go back to the roboserver view, we will actually see, okay, we already see the 3rd one there and the 4th one is there as well. So that's beautiful to see. And if we then go back, let's run some more of those robots, shall we? There we go. Just start a number of them and see how quickly we can get this to 8 or 9. There you go. So let's go back to the Kubernetes dashboard and have a look at the pods that we have. So we see the new ones being ramped up, and we can now wait for all of the others to come. Oh, here we already start to see some beautiful things happening. It has now scaled up to 8 because of the load that the others are under. So if we then go back to the admin and the robo service, refresh this, and we'll start to see additional ones popping up. So these are still starting. Perfect. That's great. And let's see if we can get this up to 9 or 10 even. And these are of course very heavy robots that I've developed for this. There we go. Let's have a look and see how full the actual queue is. No, it's not that bad. But let's have a look at the Kubernetes one. Okay, we are now scaling up to 10. So that's the actual maximum. And let's wait until we see all of them appearing here. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So we have the full maximum number of robo servers running, and the sole reason was the load. So I hope you enjoyed this demo, but just to recap, what did we actually do during this almost half-hour long video? First, we enabled Kubernetes in Docker Desktop. I talked about how to prepare a proper manifest for Kofax RPA. We talked about the metrics server and how to set up Kubernetes dashboards. I then showed you how easy it is to deploy RPA on Kubernetes. And I showed a live demo on how autoscaling is able to, well, on the one hand, ramp up additional roboservers, and yeah, you have to believe me on my word, it's also capable of scaling them down and, well, actually getting rid of these additional roboservers if the load is too low. But all of this is, of course, mainly meant to show how scalability, portability fit into a future state enterprise architecture. So I hope to inspire everyone who's watching this video, and if you've got any questions, please feel free to reach out to me or to your local Kofax representative. I'm going to continue on this journey with you on modern architectures, and feel free to reach out through LinkedIn, through comments, you name it. For now, I would say stay safe, stay healthy, and I hope to see you next time. Take care. Cheers.